Hi, this is James from Ortesi 3D printed braces and orthotics. I'd like to introduce Ortesi's cycling orthotic. The biomechanics of cycling vastly differ from the biomechanics of walking and running. When walking and running, our foot, ankle and limb is required to dissipate ground reaction forces. It achieves this through converting vertical force into rotational forces at various joints such as the mid-tarsal, subtalar and knee joint. Cycling is a closed-chain sport where the conversion of vertical force into rotational motion is counterproductive. This would result in a loss of power and likely symptoms at the anatomical regions that are absorbing this rotational force, such as the knee joint. Some common complaints cyclists present to a podiatrist for are knee and forefoot pain. All can be as a result of poor cycling biomechanics. It is important that the bike is set up properly, and this can often be done at a local bike shop. The cleats and cycling shoes should be positioned at 90 degrees in relation to the pedal. If the foot is externally rotated or internally rotated, this can likely cause in knee or ankle pain due to the repetitive nature of cycling. The principles of a cycling orthotic is to minimize hindfoot pronation and facilitate locking of the mid-tarsal joint, thus maintaining the foot in a rigid position and reducing any loss of power. It is also important to maintain good knee biomechanics. During regular gait and running, the leg in swing drives the center of mass anteriorly due to the inverted pendulum system. The inertia generated in the swing phase externally rotates the hip, femur, and lower leg of the limb in mid-stance, causing supination of the subtalar joint and a locking of the mid-tarsal joint in preparation for the propulsive phase of stance. As there is no swing phase in cycling, this anatomical mechanism is not engaged. The features of an Ortesi cycling orthotic is that it's extremely low bulk, low weight, and uses a narrow concave wedge design, maximizing hindfoot inversion and pronation of the mid-tarsal joint. We achieve this in part by using an extended distal shell under the 5th to 2nd metatarsal heads. This device can be ordered in polypropylene, polycarbonate, or 3D printed. I would recommend polycarbonate due to its high stiffness and low weight. When ordering a 3D printed cycling orthotic, I would recommend printing in either 3D smooth or 3D shock absorption, as they maximize material stiffness. It is also not often necessary to use hindfoot posting on a cycling orthotic, as they are designed to fit very snugly into the shoe. When ordering an Ortesi cycling orthotic, please just state cycling orthotic on the prescription. If you'd like to order a conventional custom orthotic for cycling shoes, please state orthotics for cycling shoes, which we will minimize the bulk. Thank you for your interest in Ortesi's cycling orthotics. Should you have any questions, please contact me, james@ortesi.com.au.